we're going to make this car assembly that I handed out. I think assemblies are one of the funnest things on Fusion. You get to put all the parts together into a thing that where the parts interact with each other. It's also, though, kind of there are little pitfalls and stuff. You have to do all the steps kind of right, or else things look like they're working, and then when you're relying on them, they're not working. So we're going to go through that. Before we get to assemblies, I'm going to show you one thing. It's quick and easy. But that is doing sort of a softening of edges. And there are two ways to do that: chamfers and fillets. So I'll show you where to do that. That's something that I think a lot of you will probably want to use on your Fusion design projects. And then second, we're going to do assemblies. Okay, so everybody log into Fusion 360. And we're going to start out by making that car body from the quiz. So on that car body, did you do that with a extrude command or with a revolve command? Extrude. And so which side did you do the sketch in? Did you do it on the side of the car, the front, the back? Side. So that's what we're going to start with. We're going to do a sketch. We're going to sketch the side view of the car. We're going to put the dimensions in the sketch, and then we're going to extrude it out. So go to your whatever folder you want to put this stuff in. Since we're doing an assembly that has multiple parts, so it might be a good idea, actually, let's do this. Let's just all make a new folder. So go to the home thing, go to new project, and I'm just going to put car assembly into this. And that's where we're going to put all of the parts. And once you make that new project, make sure you're inside that folder so that when you make the parts, they'll go into this folder. And once you're in this folder, I'm going to go to sketch, and we're going to start sketching the side of the car. So I'm going to go from here, I'm going to go 6 inches this way. I guess I'll put that dimension in now. And then I'm just going to continue kind of the rough shape of this. We'll do the dimensions to make it precise. Let's see this one. Yep. So there's the rough shape of the side. And I'm not going to put the holes in yet for the wheel axles. I'm going to first extrude the solid part, and then I'm going to go back and extrude those holes through. And let's see what dimensions we have. The dimensions are a little funny, but so we know that it says that the angle from this axis to here is 120 degrees. That means that the angle between here and here is 60. So you could use either one of those dimensions, whichever one pops up. So I'm going to go to the dimension tool. And I'm going to calculate the angle between those. So that's 120. Give a laptop with me. Give a laptop with you. And then this dimension is 1 inch. That was already 1 inch. Now the angle between this and this so I clicked on these two things and it gave me the angle between this and this, which is over 90 degrees. The one that's given on the dimension sheet is from a horizontal like this to here, and it says that that's 40 degrees. So that means this bigger angle, they have to add up to 180, so the bigger one has to be 140. So you can use either one of those, 40 or 140. And then it gives the dimension of that windshield as 1.5. Yep. So I'll make that 1.5. Okay, and it looks like this distance here is 2 inches. So I'm going to make, it's already 2. So, okay. Yes?
Wouldn't that large angle be 130, not 140?
Let's see. It says that, so it says that the angle between this horizontal and this is 40. And this one plus this one has to add up to 180.
Mm-hmm.
So 40 plus 140 is 180. Okay. Keep checking me on that though, on that stuff. Okay. So that looks good. Anybody need more time to get to this point? Yep. Okay.
Can you show how to do the 140 angle?
Yeah. So when you get into the dimension thing, if you just click on one line and then another line, it'll let you, as long as if they're parallel to each other, it'll do the distance between them. If they're not parallel, it'll show you the angle, and then you can just type it in. Question? So now we got this thing. Now we can extrude it. And the thickness of the car body is 4 inches. So after you get out of the sketch, highlight the shape that you want to extrude and go to the extrude. And we just want to make that distance 4 inches. So there's the shape we have. Anybody having trouble getting that shape? And now that we have all of the solid stuff, we need to cut the holes through the car body for the axles. So I'm going to choose this as a place to make a sketch, and I'm going to just sketch two little circles, and I'm going to, sort of drill those circles all the way through. So select that, go back to sketch. And I'm going to make my two circles here. Those are obviously by far the wrong size, but I'm going to enter the sizes and stuff just in the dimensions. And now for the dimensions, I want the distance from the center of the circle to the base of the car body to be 0.15. I'm just noticing it thought I was trying to avoid this when I put those circles in funny places and stuff, but yeah, I was trying to avoid having it make decisions on its own, but it made the decision that this hole should be touching the bottom of the, should be tangent to the bottom of the base. So I have to delete that constraint. So you can see that constraint that looks like Green Lantern's ring. So I got that out of there, and now it'll let me make it whatever I want. So now I'll go back to the sketch dimension, and I want that diameter to be 0.2. And I want the distance from the center to the front of the car body to be 2. And now I'm going to do the same kind of stuff on the second one. So I'm going to make this distance 0.15. I'm going to make the distance from this point in the back of the car to the center of the circle. Oh no, that's not how I did it. So let me cancel out of that. The dimension I really want is from the center of this little circle to the center of this little circle should be 3 inches. I don't know why it's not letting me do that. There we go. Okay, so there are the 2 holes. And the axles of the wheels are just going to go straight through those 2 holes. Anybody need more time to get to this point? Okay. So save this again, go back up to the disk, save it again. And now this is a little scary, but you can just close this. It's already in our, so. But if you go back to the folder contents, you can see the car body there. And now we're going to make the wheel. And we only have to do one of them. So for this one, we're going to use a revolve. So I'm going to start again with a sketch. And remember that with a revolve, you're always looking for the okay, well, so I'm gonna do this. I was gonna say you're always looking for the axis of symmetry. So the axis of symmetry goes, you can think of it as it goes right through the axle of the wheel. So I'm going to do something like this. And I'm going to make this 0.2. Oh, I'm going to make this 0.6 because it's the radius of the Jesus. Okay, I'm going to do this again. Okay. To avoid stuff like this, one thing that always works is do your first line and do the dimension of your first line, and then then everything else you do is roughly the right size. Yeah. What did he say about the ceiling?
They don't know, but they're going to send somebody.
Okay.
Out. Yeah.
So you might have an actual person call police.
Yeah. Okay, so I'm going to go from here to here, and I'm going to make that a distance of 0.2. And then I'm going to go here to here and make that a distance of 0.6. Okay, and then that. That. Okay, so that is about it, I think. Oh, and also there's a hole in the back for the axle to go through. I could have put that in now. I forgot to though. So instead, I'm just going to do the revolve, make the wheel, and then we'll go to the back and just drill that hole out. So that's fine. Just extrude it out.
Does the dimension of the rim matter?
Yes, and I did not give it, but I think it is. Maybe that's 0.2 actually. Mine looks a little small, doesn't it? So I'm going to make this 0.2. I think that's more like it. Maybe it was 0.15. Okay, so now We have everything there. I'm going to finish this sketch. And now I'm going to revolve this. So select inside the shape, highlight the whole thing, and click revolve. And the last thing it's going to ask you before it can revolve it is what's the axis that you want to revolve it around. If you can picture what I'm doing here, I want this shape to swing all the way around like this. And so my axis of rotation is this, my revolve axis. So my axis is this, and it makes the shape. And you don't have to revolve it 360, but that's always the default. Hi, come on in. We can. That's right. So, okay, so yeah, the default is 360, but if you wanted to just make a quarter of that wheel or something, you could do that too. And one thing that's not in this picture that I want to do is I want to drill. It's not in this picture of the wheel itself, but it's on the picture on the front. I cut a hole out of the wheel just so that when we make this assembly and watch the rotations happen, we can see the wheel moving, you know? So let's rotate to the back of this. And first we'll just drill an off-center hole through. So I'm going to go to the back, choose the back, and I'm going to do a sketch. And it doesn't really matter where you make this hole, as long as it's off center, so that when the wheel rotates, you can see it. That works. And I'm just going to drill this all the way through, extrude this all the way through. No, don't worry about the dimension. Just make sure it's off center. Oh, and I guess you want it to be small enough that the yeah, you don't want it to interfere with the hole for the axle, I guess. So keep it a little ways from the center of the circle, I guess.
You don't have it overlap with that hole for the axle?
I don't think so. We'll see. Okay, and this goes all the way through. Let's see what we have here. A hole. Okay, and now I'm going to do a similar thing, but this one isn't going to go all the way through. This is just going to be, where the axle goes. And this one is going to have a diameter of 0.16, I think. Yeah. Bless you. And when you're done with that sketch, you can select it, go to extrude, and this time, you know, we're going to extrude a hole, but it won't go all the way through. It'll only go 0.1 in. So that's just going to hold the axle. And if you want, again, you could use fillets on this. I'll try 0.1. Ah! 0.1 was too big. Okay. Looks sort of nice. Yep.
I might have missed it. What's the off-center hole for?
Oh, because when we make the assembly later on, when we put all these pieces together, we're going to be able to watch the motion of the wheel to make sure that it's all aligned the way we want.
Okay.
And if you don't put that in, the wheel will be rotating, but you can't tell.
Okay.
So this is just for us to like look at it later.
So is it an arbitrary size and then an arbitrary?
Yeah, it's arbitrary size off center so that yeah,
Okay, thank you.
so that you can see it moving.
What did you do with the 0.16?
Oh, so after the hole all the way through, I made a hole with a diameter of 0.16 here. 0.16 is going to be the diameter of the axle, and I just extruded it 0.1 inches in. Yeah, that's what worked. 0.1 made a whole bunch disappear. By the way, so I just entered a value of 0.05. A millimeter is just under 0.04 inches. So I think as like a good kind of rule of thumb type thing to remember, features that are less than about 0.04 inches are not going to work well with the 3D printing, you know? So think of that as kind of like a cutoff. That 0.05 is, if we 3D printed this, I'm not sure it wouldn't come out looking very clean probably, although you probably could see a little bit that it wasn't a sharp edge. And yeah. And save it as wheel. Or whatever you want. And once it's saved, not before it's saved, but once it's saved, you can close that. We're done with that. And if you go back to the folder, you have the car body and the wheel in here. And I didn't give dimensions or anything for this, but now we just have to make the axle. The idea of this is like, if you were actually making this as like a Pinewood Derby car or something, you might 3D print the wheel, you might 3D print the car body. You would very unlikely 3D print the axle, you know. You'd just buy like a metal piece or something that had the right diameter. So that isn't something that we would make ourselves probably, but we need it for this assembly. So
how snug of a fit do we want it?
So on this, we want a snug fit. So this is gonna have a diameter of 0.16 inches. Okay, but we don't. If you notice, the holes we made for the car body were bigger than that axle dimension. So we don't want a snug fit between the axle and the car body, but we do between the wheels and the axle.
Would it be better to have a hollow car so you have less friction between the car and the
Possibly, but we didn't do that. Okay. Although we'll do this calculation in dynamics.
Good.
Do you know what goes into, so what's the key determinant of how fast a Pinewood Derby car goes? Besides friction and stuff, like that's important, but the key thing is like a ratio. Well, it's kind of a complicated ratio, but basically like you want the car body to be really heavy.
Yep.
And you want the moment of inertia of the wheels to be really low. So you want a big ratio of the mass of the car to the moment of inertia of the wheels. And so in fact, if you're using the same wheels, this thing would go faster with a solid body than with a hollow body. Kind of makes sense. But like when you do the when you do the Pinewood Derby, that's why they're really careful about the weight,
Yeah.
because you could keep making it go faster and faster by, if you made it 50 pounds on top, it would go really fast.
Yeah, do they have like a weigh-in before?
They do. Yeah, very careful weigh-in. That's what makes it a hassle, is that's why everybody's there, like standing around this table with tools, like adding little weights and then weighing it again and then shaving off. And yeah. Okay, so now we're going to do that axle, and that's easy to do. You could either do this as a revolve or an extrude. I guess I will do it as an extrude. So I'll make a circle like this with a diameter of 0.16 inches. And then we have to think about how far to extrude it. So it's 4 inches to get through the car body. It's 0.1 inch on each side to join with the wheels. So that's, now we're at 4.2, and then we're going to give it about a millimeter of wiggle room on each side. So that's another 0.08. So let's make this 4.28 inches long. So that's how long we're going to extrude it. And once you get that, you can save that as axle. And once you save that, we have all 3 of these parts in here. And you can close the axle. So now we're going to get to the cool stuff finally, which is putting these pieces together. The first one, we're going to do kind of a simple case where we're going to take, we're going to make an assembly that puts a wheel on each side of this axle. And we don't want the wheels to rotate on the axle. We just want the whole axle to rotate in the car body. So I'm going to make an assembly where a wheel is fixed onto the axis on both sides. So first I'm going to go up here and I'm going to create an assembly to put all this stuff in. So go up here to New. And it gives you a bunch of choices, and we want the assembly design. That was from the other room, I think. And so now the first thing you have to do in any assembly, so we're going to make an assembly that's an axle and 2 wheels, and then we're going to take that assembly and bring it into another bigger assembly. So the first thing you have to do is choose a component and that is going to be fixed to the ground, and everything else, anything else that moves in reference to the first thing. So the first thing I'm going to bring in is the axle. So go up here to Insert. And we want to insert a component. And this component thing is important when you're doing assemblies. Like right now, these are parts, okay? But in an assembly, if the different pieces that you're going to join together have to be components. And so we're going to tell it that the first component we want to bring in is this part that we called axle. So we'll insert component. It'll ask us what we want. Click on axle. And that thing's in there. And you can decide if you want it to be a different orientation. You know, you can You can rotate it around like this, this, you know, you're just picking a way that it's easy for you to look at. You can move it up or down, but when you find something you're happy with, you can click OK. And now that's sort of the base of your assembly. That's the base part. Anybody need time to get to this point?
Quick question. How did you get to the assembly thing again? Because when I
Yeah.
clicked on the little file icon, selected the assembly, just in a different menu.
Oh, okay. Let me look.
Yeah, that's the same thing.
Do you have an installed version, or is this the online version? These are all safe. Maybe yours, you have it in safe.
I did notice when I clicked on the little looking at this information.
That's different. We can look at that later. Okay. I don't know. Let's just work with it like this and see. Well, no, you need because you need writing. Oh, okay. So I think you're okay, like with this as a design, and now you're gonna insert components here. I think that will work. Anybody else? Oh yeah, I think you have the same. Yours is just slightly different. So you have a new file here, and you're going to go to this menu to insert components. But I think it'll look just the same as mine does. So this is your new design already, and now you'll just use this menu to insert components. I think that's all. Hopefully, we'll see. Yep. Yeah. Is this installed? Or is it downloading?
No, it's like that. And then it's tangent.
And then yeah, and then you're just going to use go to assemble, insert component. So I think you're just going to use this menu.
I use candy because then I'm pretty much. Okay. Yeah.
Okay, so once you've brought the axle in, now we're gonna. And one thing to notice about this is that in your menu here, when you brought the axle in, it says so. This chain thing says that it's a component in an assembly, and notice that there's that little anchor there that says that this is my ground component. So this is the one that everything else is going to be like referenced to. When I bring in the wheel, it's not going to have that anchor. So now I'm going to go back up to insert component. All the people who have the installed version, just go to your assembly drop-down menu and go to insert component. And we want the wheel. And I'm going to rotate this around just so I can see the, like really all I want here is I want to be able to see clearly that hole that's going to join with the end of the axle. So you can use these rotation things to get it in the right position. And once you have those two things in, now we're going to create a joint between these things. So on mine, I go to relationships. Let me know if you have something different on the installed version. Okay, so go to relationships, joint. And before we enter any of this stuff, switch over to the motion options. And you can choose, like most of the time in assemblies that you'll make, the most common one probably is a revolute joint. That's like a wheel spinning, you know. That's one that rotates around an axis. For this one, though, we don't want it to spin freely. We want it just to be a rigid joint, like these things are glued together. So I'm going to choose a rigid joint. And now I'm going to go back to position. And it says, so there's a component 1 and component 2. And I think everybody in the world would say, like, what would you call your component 1? That's going to be the one that's fixed, and your component 2 is going to be the thing that moves around it. That makes so much sense. So they did it the opposite of that. So your component 1, it doesn't matter in this case because they're all fixed together. But later, when that axle is free to spin inside the car body, you're going to want to choose that axle to be component 1 and the car body to be component 2. So, okay, component 2, I'm going to go in here. I'm going to try to highlight the center of the back there. You can see it shows you what plane you're on, and I want to highlight the center. And so I'm going to join that point with the center of this as my component 2. And when I do it, it'll just jump right into place. It chose the correct direction. It could have just as easily chosen the opposite. And so there's a thing down here that just says flip if it so if that pops on backwards, you just hit the flip button and it pops it around 180 degrees. But so this one's good. Now we have to do the exact same process one more time on the other side. So I'm going to insert the wheel again, insert component, wheel. Whoops. Well, that's all right. So go to relationships, joint. Make sure the joint type is rigid. And then for component 1, we're going to choose the center of the back of that hole. There. And for component 2, we're going to choose the middle there. And it pops right into place. Oh, and one thing, if we cared about, it doesn't really affect us right now, but notice that these wheels are in different orientations. If we wanted it to look nice and clean and have them in the same orientation, we could go back into this timeline here, go to that joint that we just did, edit the joint, and we could rotate that angle to make it match up. Okay, so that is our wheel assembly or axle assembly or whatever. So let's go up here and save it. Yes. Okay. I'm going to bring in first, I'm going to insert as the first anchor component, the ground component, the car body. And that is fine. And then I'm going to insert another component, and this is going to be the wheel assembly. And move it so you can access any of the stuff that you'll need to see to put it into place. That works. Okay, and I am going to try to, so now we want the joint, right? So I'm going to go to joint. This time we don't want it to be fixed. We want it to be able to spin freely. So go to motion and go to revolute joint. And now remember that the order that we want to do it, the component 1 is going to be the thing that's spinning. Component 2 is going to be the thing that's fixed. So my component 1 is going to be the wheel assembly. And I want, so this is kind of a funny thing, but the point that I want to base everything on is the point at the center of is basically this point right here. But it can be a little hard to select that. It seems that on mine, I can select the plane sort of first, and then it'll let me go and select that point. So that's kind of like a, that seems to work in this case. Otherwise, it was like, it wasn't trying to snap to that point because that's not the end of the axle, you know. Okay, so that is our first point, and now we want to snap that to this. And now it's almost done, but remember we gave it that extra 0.04 inch wiggle room. And right now those 2 points are pressed right against each other. So we want to move it in this direction, 0.04. So I'm going to slide it in the direction I want. It doesn't matter how much. And then it asks you how far you want to do that, and just change it to 0.04. Look at that thing. That's beautiful. And now if you want to see what it looks like as it spins, make sure that it's all oriented right. You can go back into that joint, click edit, and I think it's under motion, and you can preview the motion and watch this. It's going in reverse. But so wait, what happened to the other wheel? Why did it leave it there? It's not supposed to do that. Oh wait, the whole axle's gone.
What? Only the wheel came through. Does it only move the wheel? Only one wheel?
Hold on, let's see what happens when we. Oh no, it did it. It just, I don't know. That was just for the view. It would have been more satisfying if it didn't do that, but it worked fine. There's the axle is in there and stuff. Go down to the joint in the timeline and right click, and you can edit the joint. And then under motion, you can preview the motion. And there's other stuff that you can mess with. You can try motion studies and whatever. Okay. Now we just have to do that one more time. Put in the axle assembly one more time. And so I'll go back up to insert components, get the wheel assembly. It doesn't matter that you've already put it in there. You can put it in several times, and I'm just going to rotate it so it's easier to see what I need to see. Oops. That's okay. And now I'll go to joint, relationships joint. Be sure you make it a revolute joint. Oh, I think patience is a good virtue with this for just making sure that you're selecting the right points. It's pretty easy to select the wrong point. If you're just tired of zooming and rotating and stuff, you sort of get like, oh, it's probably guessing right or whatever. But there it is. And then, oh, and that one I think I didn't. I forgot to adjust the height. So let me go back in and I forgot to give it that extra wiggle room of 0.04. So I'll go back in here. I want to go that direction, 0.04 inches. And now there it is, a car. Now you don't even have to buy a car. You can take this to school. And then if you wanted to 3D print this, well, like I said, you probably wouldn't 3D print the axle. You would probably just buy that. But if you did want to 3D print this, you could 3D print this whole thing like that. And since we have that wiggle room in all the joints, it would function. Those wheels would rotate freely. Or you could 3D print the parts individually and then fasten them together. So you could sort of choose how to do it. Anybody have any questions about this? Yes.
When I tried to 3D the revolve, it shows the axle, the wheels like go back the way they started.
Yeah. I don't really have an answer to that. That seems like what mine did too. Mine just did it with the wheels and left the axle behind. So I don't know. There's got to be a way to not do that. But like when you're not doing the preview of the motion, it's all in place. That's how mine worked too. I don't know what to say. Any other questions? Okay, so some of you might find this assembly useful for your design project stuff. I guess that's all I have to say today. If anybody wants to talk about your design projects, I'd be happy to do that. Just let me know. Otherwise, you're free to go whenever. But yeah, I'd be happy to. So the assignment for next week is going to be a simpler assembly than this, and then like sort of the next step in those design projects, and we're going to finish those pretty soon. So, okay, that's all.